Hey, Math 206. This is Dr. McGathy, and we'll be discussing properties of triangle congruences and do a few more constructions. So, first of all, if two triangles are congruent, if it's possible to fit one figure on top of the other so that the matching parts coincide, that means that all of the side lengths are going to be congruent, and also the angles in between two congruent sides will also be congruent. So three sides, three angles, all matching parts congruent. So let's see, for these two triangles, I know, for example, that triangle ABC is congruent to the other triangle. If I started with A here, let me find the vertex with the same markings. That's A prime. And then going to B, so I'll follow along the line segment that has the same marking as the triangle on the left. That gets me to B prime. And then the last vertex, I'll name it C prime. So in this case, triangle ABC is congruent to triangle A prime, B prime, C prime. Let's now name all of the parts of the triangles that are congruent to each other. Start with the side lengths, or the sides. So AB, this side, which has one tick mark, is congruent to side A prime, B prime. BC is congruent to side B prime, C prime. And AC here, or you could have called it CA, is congruent to A prime, C prime. So these are all the side lengths, or the sides that are congruent to each other. Also the angles. Angle A is congruent to angle A prime. Angle B is congruent to angle B prime. And angle C is congruent to angle C prime. Now it turns out that you always have, if you have two triangles that are congruent, you always have that their corresponding parts are congruent to each other. And we'll actually use that a lot in the proofs that we do in this section. It's called CPCTC, and it stands for corresponding parts of congruent triangles are congruent. So we'll be using that in some of our proofs. Let's start an example. Let's write an appropriate symbolic congruence for each of the pairs of the congruent triangles below. So for example, these two triangles are congruent because they're two right triangles. The legs are the same length, 3, 4, 3, 4. They both have a right angle. And so then you kind of get that hypotenuse for free. So here I know that triangle ABC is congruent to triangle. Now let me find the vertex that corresponds to A here. It is on the angle that is between the hypotenuse and side length 3. So here's the angle that's between the hypotenuse and side length 3. Call that E. Now let's find the part, the vertex on this triangle that corresponds to vertex B here, in between the hypotenuse and side 4. So that would be F, in between the hypotenuse and 4. And then the remaining C is then congruent to D there. So triangle ABC is congruent to triangle EFD. Let's do the same thing over here for these two triangles. I'll say triangle ABC, and hopefully it's congruent. Let's just double check. What are the three angle measures here? Here's a 90-degree angle, 60-degree angle. I know these have to add up to 180, so this one has to be 30 degrees. And over here I've got a 30-degree angle, 90-degree angle. Since they add up to 360, this one also has to be 60 degrees. And they both have side length 4 here. So let's write down the congruence. ABC is congruent to triangle. A is a 60 degree, so I'll write R first because that's the 60-degree angle. B is my 30-degree angle, so I'll write Q next. And then C is the 90-degree angle, so I'll write P next. You want to write them in a way that the corresponding vertices are in the same order. All right, so let's now discuss some congruence conditions. First one is called side, side, side. we say if three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. So given that congruence condition, okay, let me name it here. It's called side, side, side congruence. So you can say side, side, side congruence. Usually we'll just write SSS. All right, so let's decide, are these two triangles here congruent? Here my side lengths are 3, 2, 4, and I've got side lengths here 3, 2, and 4. So by, we'll say side length AB is congruent to ED. So I go from AB to BC. So I'm going to go from ED to DF. So BC is congruent to DF. And lastly, CA is congruent to EF or FE. So because the three pairs of sides are congruent, by side, 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 I'll say triangle ABC is congruent to triangle EDF. Let's take a look at this one now. Here I've got side length 5, side length 5, side length 8, side length 8, and the remaining side they share. So I've got AC is congruent to DC, and AB is congruent to DB, and of course BC is congruent to itself. So I've got all three sides of the two triangles are congruent to each other. So we can say by side, 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 triangle ABC is congruent, and let's write it in the same order. I did ABC, so it should go DBC. There we have it. All right, now let's end with a construction that sort of shows why if you're given three sides of one triangle, there's literally only one triangle that can be drawn with those three sides. The way we know that is because we can construct the one and only triangle with those three side lengths. So let's start here by constructing a triangle if we know the three sides of the triangle. So I'm here given triangle ABC, so side length AB, BC, AC. I'm going to construct a second triangle that has all the same side lengths as the first triangle, and I'll see that there's only one possibility there. So first step one, I'm going to construct a line segment, A prime, C prime, that's congruent to AC. So we saw how to do this in the last video. I'll start by just setting a point and calling it A prime. And now I'll take my compass and I'll set it to the length of the segment AC. Now that I have that length set, I will translate that over here, draw a little marking. So I'll call this step 1 here. I'm going to circle that with green so you can see. So step 1 was to draw a mark that is the same distance away from A prime as C is from A. And then I'll connect those two markings by a line segment. Then this vertex here will be my C prime. So I've got one side of the triangle copied over. Now I need to copy the other two sides over. I'm going to use two other colors for that. first I need to copy the side length AB over. So I'll take my compass, I'll set the vertex at A, the point, the center at A, and then my pencil at B. So now I have this length copied, and I will bring that over here, setting the point at A prime. And I don't know exactly where B prime is going to be, but I know that it'll be this distance away from A prime. So what I'm going to do is to just, what I'll do is to draw a circle using my compass of that radius. So this denotes all the points that are that distance away from A prime. Let me just go over it a little bit darker. All right, now I'm going to switch colors here just to demonstrate. And I'm going to do the same thing with side length BC here. I'll set my compass arms to the length of this segment, and starting here with the point at C and the pencil tip at B, I'll set the point at C prime. This is that same length. And notice I can draw a circle that denotes all of the points that are this distance away from C prime. All right. So now I notice I have two intersection points from the blue circle and the orange circle. So that gives me actually two possible triangles that I can draw, but you'll see that they're actually equivalent to each other. So I'll call this B prime up here, or this could be, B double prime down here. Connecting those, A prime to B prime and B prime to C prime. Gives me a triangle that has all the same side lengths as my given triangle. Here is side length AC, side length AB, and side length BC. All right, now, and then you could also, this is a second triangle that you could draw, but you'll see that it's actually equivalent to the one that's kind of above the line here. All right, and this shows us actually we could have done a shortcut. We didn't have to draw the entire circles here to show the distance AB and CB. We could have just drawn just part of the circle so that the two circles intersect. So let's actually do that. We're going to go through this construction one more time, just a little bit quicker. I'll draw A prime here. Let me find B prime by setting, or C prime, sorry, by setting my compass arms to that length. So there's C prime. And now I can find the length AB using my compass. Set that compass length to AB, start here at A prime, make an arc there, and then set my compass arms to length CB, setting the point at C prime, make an arc so that this arc intersects with the other arc that I drew. And there is the third vertex of my triangle. And then you can connect all the vertices to have that triangle copied over.